So let's start our panel. And do we have our panelists? Mhm. Great. So for our panel, we have Phil again. We also have Juliana and Rahman, who are both faculty members here at Penn State. So before we begin the panel, I'll give you the panelists just a few minutes to introduce yourselves. So we'll start with Rahman.
Hello, everyone. My name is Rahman Azari. I'm an associate professor of architecture at Penn State, and I also run resource and energy efficiency RE2 lab at Penn State. My main area of research is about environmental life cycle assessment, quantifying the environmental impacts of buildings, energy efficient buildings, and in general, sustainable built environments. Thank you.
Great. Thank you, Rahman. Glad to have you. Juliana.
Wonderful. Good morning, everyone. I'm Juliana Vasco. I'm an assistant professor of agricultural and biological engineering. And my main, my lab is, we work mostly in sustainable systems analysis. So we do techno-economic analysis and life cycle assessment of emerging technologies for bioprocessing. But I also trained as bench scientist for many years, and I worked with fungi, worked fungi, mostly for the constructed materials. So kind of the opposite of what most of you are interested in, instead of building, kind of breaking down biomass to make chemicals. So I do have experience in biological part of this area. We're still very interested in working with this type of fungi, and we also work a lot in lignin valorization, so using those parts of the biomass to make other bioproducts. So very interested in the bioproducts area and in bio-waste products area from the bigger perspective, trying to understand really how we can make these materials really more sustainable and economically feasible so they can compete with traditional materials.
Thank you so much, Juliana. And Phil, I'm just going to ask you to introduce yourself really quickly, just for any participants on Zoom or even in person that may have joined midway through your presentation or just now.
Sure. My name is Phil Ross. I'm the Chief Technology Officer and the co-founder of MycoWorks, and we are a company in California that grows textile-like materials for the fashion industry using the tissue from the body of the mushroom that we grow.
Great. Thank you so much, Phil. So we had a lot of questions from your talk on Zoom. So I'm going to start us off in this panel discussion with one of those questions. So one of the first ones here comes from Victor Thomas. Do you have any information about the longevity of micromaterials? Any way to increase that?
Yeah, that's what we do. We are stress testing the sorts of things that we do. The advanced environmental testing are, that is the closest thing that we can get to an understanding of how they will age. And we tie these to comparable material tests for other materials. So we have some way of understanding that. So that can be like bending it. I showed one of these machines that will sort of bend a piece of the leather back and forth tens of thousands of times to see if it cracks or how the surface behaves to that. We do things that, where we have to, get a piece of white silk and get it wet and then rub it against a piece of that black material thousands of times to see if the dyes are going to come off onto that silk. So we do all that sort of testing, and that was just part of, I shared some of that data, but again, like that's how we understand that they can age and do these kind of things in the same way. And we do that to match the leather types. So all leathers are different, and luxury leathers have a particular set of performance expectations that they have to fulfill that are very different from, say, the leather that might go into your belt or a glove. And so we are able to reach all of those. So that's, you know, so they age comparably, and then depending upon how you seal them or other sorts of protections that you put on them, that will also change them. So like animal leather, there are just a lot of ways you can determine the variables depending on how you process them.
Definitely. And just one more question from Zoom that I think is going to be really nice to transition to the academia realm, because it's associated with college degrees. So this one comes from Camellia Cantor. Excellent presentation, Phil. Phil, you mentioned that the new facilities in Union County, South Carolina, and they focus on work development or workforce development. Are they only looking at those without college degrees, or also college students or college graduate trained in fermentation, but with potential opportunity for employment at their education level?
Yes, yeah, it's across the board. We can hire some people who've maybe never had a job before ever, or have worked at a fast food restaurant or something like that, and can follow basic instructions. There are those entry-level jobs, or ones that can take some further training with someone with that, you know, might have a GED, might not even have a GED. Level, to people with PhDs in genomics, and people in manufacturing. We brought in a team from Procter & Gamble who had worked there as really sort of a whole division or set of people to come on board with us to help us. So those folks have a lot of industrial manufacturing, you know, robotics, Python controlled, you know, programming environment, you know, just like the whole scale. So we have, again, as I said, and we collect a lot of data. So we hire people who have, you know, can write software and can do image, you know, acquisition. Just, you know, it's sort of like, it really is everywhere that we need employment all the way through the production stream and value section. You know, we just a lot of people are like, what could I do? What should I get into? And I was like, whatever you do, it's good. Like, it's really, we need the skills of everything. So it's like, just sort of figure out how to get closer to the thing. But accountants, you know, whatever, it doesn't really, you know, it's like, there's no mysterious combination of qualities. Like, it's sort of like just doing anything. You need you need all the experiences to be applicable into that. Just mainly interest is the other ingredient.
I can definitely understand that, because I think as faculty members, you know, when we're thinking about graduate students, there's a lot of workforce development. So I'm curious, Juliana and Rahman, in your particular research areas, what are some of maybe the challenges or opportunities that you see in workforce development?
I can start if you want. I think we see a lot of these combination of within the area of fermentation and bioprocessing, a lot of that combination of, okay, it's the new thing, and there's a lot of opportunities and growing markets, but also sometimes the students struggle to find the right jobs. I guess, you know, with a combination of locations. So I was thinking, Phil, when you were talking about it, and how we train a lot of students in fermentation, but they sometimes struggle compared to other engineers, especially to find jobs initially. You know, when they find the jobs, they're usually very good and they're very happy. And our students have a lot of good placement in that area. But I've always kind of, as a biological engineer myself, I've always had the struggle of encouraging more people really to join this workforce, because I think it has grown slower than we were expecting 15 years ago or 20 years ago. and you know, training too many people in this area, it could also be, you know, a potential downside. So I kind of want to go back to that and think, really, do we need more people training for bioprocessing and fermentation, really? Or is it difficult to find them? Because we feel like, for me, sometimes I do, but usually it's the right combination. A lot of the students that we get, at least for grad school, have a lot of experience in bioprocessing from the experimental perspective, but they don't have coding experience, or, you know, programming experience, or things that we do need for the systems analysis part. If I want to put them to do techno-economic analysis, they have to do optimization. Most of them have never done optimization before, or they have to be able to write code in Python to develop a truly new method in life cycle assessment or in techno-economic analysis, and they don't have it. That's where I struggle finding those skills, not really the fermentation ones, but I just don't know. Phil, how do you see that?
That's fascinating. What about you, Rahman?
No, I completely agree. One thing that I can speak to architecture, the realm, from my experience with architecture students, I have seen that they are pretty open to interdisciplinary research and interdisciplinary fields, and you could see that from the works of both the students and faculty in our department, that it could range in a variety of areas, from computation methods to the realms that intersects with agricultural sciences, to engineering, to medical even. So I think that we have this initial step that should be about openness to other cultures and other disciplines. I think what we need to reinforce is, as was mentioned, it's about the development of skills that for the students to go to other realms and be successful. And I think what this workshop and the works of the faculty like Benai, I think we're going to add these skills to the tools that our students are going to have.
I would just like to kick in, because I was a part of academic, I was a professor for over 15 years, and now that I've seen this other side of the world into this, and I think like what the humanities often does is, like I think of like the emergence of information sciences and how these students who are, in symbolic systems and this weird outgrowth of philosophy, and like there was no job development, there's no job placement in sight. In fact, it was sort of like, oh, you sort of like disappointing parents everywhere by going into symbolic systems. And then suddenly it was like the hottest field in the world. And all those people were hired up by Google and Facebook and have had illustrious careers developing all sorts of amazing things. And I think that sociology and anthropology also fail their students in this way of not imagining how there's actual jobs or meaningful employment for the skill sets that they've developed in, of all this years of training. And, that there are ways to get it to affect these industries by providing some kind of, even if it's conceptual skills of how to put stuff together. Like that's where my own training in the arts was so critical, is just like making a collage from what's around and advancing that forward. And that is the power of the humanities, is the ability to do that and to react quickly in relationship to culture. And so I think it's like, yeah, they don't even need huge skills. They don't need like necessarily yes, we do need synthetic biology, but we just need process engineers, like people who are good at shop class. Like we need those people. And it's an awesome entry position way. If like you're good with your hands, like you might be really good at bioengineering. Like actually, there are still places for those kind of craft hands-on stuff, and you just might need a 2-week training or something to get in the door, as opposed to the much larger things. So I think that's incumbent on the universities and the train, again, like the technical colleges, the community colleges are already addressing that, but it's just sort of like, I don't know, that's some of the failures of the humanities is to sort of continue the relevance into these other areas. They can be quite effective and meaningful.
Yeah, I really
Right.
like the reminder for the need for on-hand creativity to really venture out into unknown fields, right? And these new areas of possibility. I do want to check in with our in-person audience to see if anybody has a question at this moment from this discussion. It's okay if you do not, that's okay, because we do have a lot of questions prepared. So one of the first ones, and going back to Juliana, what you were discussing before, what do you foresee the main techno-economic challenges are for the development of any new material, new products out there?
Yes, so I think in this area in particular, and I think Phil illustrated very well with his presentation and talking about reaching these high added value markets first, because it really depends on the profitability of the product and how much money they can make with it, because the process is still the challenge and is still expensive. So we have found in our analysis mostly the sterilization or pasteurization process. It's very energy intensive and can be very, very expensive. And that's one of the main challenges when we're scaling up. So in general, it's the energy, but also the technical challenges of how to do these in the lab. We usually use these autoclaves where we can put everything inside and that's it. But then how do you do it our biggest scale? And other industries have figured it out and we can learn from them. The mushroom industry for us has been a very good example on how they do it, but also they're doing, specialized food products that are also expensive. So yes, they can keep on a sterile environment. They have to, is the only way, but these products have a lot of added value. So I think when we're making products of higher added value, like luxury products, it's very different. But when we're talking about commodity products, like in the case of products that are supposed to be cheaper or to have a shorter lifespan, and I think that's the advantage I see from using these for building materials. I feel like at least they will have a larger lifespan. But the materials that have a shorter lifespan, you have to do more. You need bigger scales. The scaling up of solid state fermentation is always a challenge economically, mostly the sterilization part, but also how to do that in an effective way, because fermentation, when we do larger scales, in the typical fermentation, we do tanks and we mix, but in solid state, we cannot mix. So, having uniformity through the whole system is very complicated. Then you get into complications of mass transfer, how to get food for these fungi everywhere uniformly so it grows well, how to get air, how to get oxygen, because these organisms are highly aerobic. They need a lot of oxygen. So if you just think, oh, we will make just big piles, or we will make these tanks that are like pack reactors, then you need to blow air through them at a rate that is huge and that it is very, very expensive to do. Or you need to instead blow pure oxygen. So they really get the amount of oxygen, which is very dangerous. So most people would say, yeah, that's not probably feasible. So I think in general, this scaling up could be very difficult if we are going to do products that are needed, in a commodity scale. And so I think that's where I see the biggest techno-economic challenges.
That is fascinating, Juliana. And I think, Phil, you were talking about the biggest challenge really being like the market uptake. And I wonder if you can talk to us a little bit more about that and expand on that idea.
Yeah. It was obvious to us from the struggles that we had to try to find a market or an application for the solid materials. Like we were just like, we would try anything. Like we made the bumpers of pallets, which use a piece of hardwood that's only, and we're like, that's an endangered hardwood now. That there are the bottoms of shipping containers, which are also made out of like particular composites, which are based on extractive methods, they're just like, and then we did the panel systems and we did all, it's just like, it was like, we just tried everything in the, what are called the interior design applications. That was sort of like the area where we were cleared for takeoff, and just like every possible thing that could manifest that or into industry in packaging and shipping. And there's like foams that go in Alvin down to the bottom of the sea that are incredibly expensive. And we were just like trying to figure out like, where can you make a luxury composite? And it just is, people are like, make a yoga brick or a surfboard, or just like, we're like, I know, I'm sure this could sell. And you're like, and then you just do a basic business analysis, which is, the cost of your goods sold versus the capital expenditures to create that. That's just like what I learned is like how much does it cost and how much can you get for it is the basic idea of capitalism. And then none of those things, you're like, that yoga brick would have to cost $300 or something like that to, and even then it would be hard to mass produce it. Or the surfboard would cost $3,000, or whatever. It was just like some extraordinary, and you're just like, this is crazy. And these are just going to be expensive one-offs. And then you've gone through the whole process of product development for something. And you're just like, and then you do the economic analysis. And it was just like, we just couldn't figure out. And I see a lot of companies now starting off again, like there's this design forward approach, like, oh, this just needs to figure out the right application. And then this will unlock the market. Like it's not a design. It's again, like I said, it's not a design. Anyway, those markets, I don't, and for us, it was just like with the leather, it was like this magical thing, a product market fit where like, we got this thing and it is solving a problem that is painful to these industries. They could not get the volume of leather of the quality that they expected in the time that they expected. And that was just a supply chain that had to do with globalization. And again, like scaling of leather, all this stuff that was just like, I had no idea that those things even existed. But then it put people at the C level, at the corporate levels, asses on the line to figure out that problem within a set number of years, or they were going to be fired. That's the reality that moved the needle, was like incentivize the CEOs to lose their jobs and you'll get the job done. You will get a carbon negative whatever, if that is the rationale. But before that, we were dealing with people at the design level, which is usually the final packaging of whatever the company or corporation was interested in. And then suddenly it was like, we're talking to people at the executive level who have a real problem. And then it was just like, this is the market. Cause like people were coming to us and being like, how can we do, like, we will pay you to help us solve, if you can help us find the pain. That this is another business axiom, is find the pain points where people are suffering and they need your services. And our services were, we could provide a uniform product with planning years in advance to know that product would be at point B, in a certain volume of a certain quality, and you just can't do that with leather at all in any form, and we can do that. And so it looks like leather enough, and so that's what it will be accepted as, and the gateway and the opening up, but it can be so much more than leather, and can be designed from the interior out and gives design capability. So I don't know, like, it's just like, I don't have a real formula other than we just, and I just want to go back because this learning the design process is really important. Learning, you get this in architectural school too. You get this in business school too, like iterate, like the process of design is important, not design forward solutions. So just that training in how to think and how to solve problems is super important for these industries, because no one has the answers. And, it'll depend on people figuring it out through iteration and being comfortable with having a problem and keeping on doing it. Like, again, like robotics, probes, medical device design, like these are the fields like we can take from. Architecture people do really well. People who've done some skills with their hands tend to do well, and also who think, are thinking and doing things with their hands. Those are the folks who seem to take well to these industries because they just have that amalgamation or the trust in both their body and their minds at the same time. So I don't know. That's like I rambled again, but anyway.
But I think, Bill, you really touched on some very important topics that I think Juliana was also touching on, and particularly the idea that you really have to identify a big gap, a big problem, and move the top people, right, the CEOs, to secure their jobs in the future, right? And I think that is really remarkable. And then the other point of the iterative design process to think about solutions, not as final as soon as we get them, but really just a version, right? And that we improve upon that version and so forth. So I really think that is a great points, and thank you both for touching on those. I did want to move a little bit into the environmental impacts. I think we have had a lot of discussion and questions about the environmental impacts of these materials before we move to some of the questions on Zoom. And Rahman, I was wondering if we can, start us off with this discussion on, how can we assess the environmental impacts of new materials, and particularly, how do we deal with uncertainty when we're implementing life cycle analysis?
Thank you very much for the great question. So we oftentimes use life cycle assessment as a methodology to understand and estimate the environmental impacts of products, processes, materials, etc. And basically how it works is that we lay out the entire life cycle of a certain product, from its production all the way to its maintenance and eventually recycling, reusing, or simply discarding of the material. So once we laid out this process, we try to track the environmental inputs and outputs for this entire life cycle. For example, how much energy goes into this process, how much land, how much water, how much emissions are involved from different sorts in this process. And then we try to aggregate these results based on different impacts that they make in terms of global warming potential, acidification, eutrophication potential, etc. So we have to develop a good understanding of what are the environmental, first, what is the process like, with the production process, maintenance process, and the post-maintenance process, and then what are the inputs and outputs environmentally to this process. I think with regard to these products, what I'm particularly very interested to learn is that what is the comparison group that we are comparing these products with? What exactly? Are we comparing this, for example, with a certain cement-based panel, for example? Are we comparing them with a certain, I don't know, are we going to use them as wall panels, and therefore we're going to compare them with a gypsum board, for example? So because that comparison group would help us compare the apple to apple, and then be able for us to say that, okay, so this product is certainly 50% or so the improved or better environmentally with regard to global warming potential as compared, for example, with the product X. So defining that comparison group is very important. And to be able to do that, we have to first know what is the properties of these materials, because properties derive performance, and performance derives, I would say, application. And then once we have the application of a cert based on the properties, architects usually make decisions based on a few factors. One, what is the performance and the application of a certain product? The second is that what is the environmental impacts of this product? Third, what is the cost? And fourth is what is the perception of aesthetics? So I think in all of these four categories, we have to develop a good understanding of these materials and products. For me, a curiosity is that are these materials going to have thermal resistance, for example, properties as well? Because if they do, then we could argue that these would be good insulation materials, and therefore their environmental impacts is not just limited to whatever global warming potential or etc. they would have, but also they could lead to energy savings during the use phase of the buildings as well. And that could be another layer of defense for these materials, to use these materials.
Yeah, that is a fantastic discussion, and I really appreciate the functional unit discussion that you just shared with us. I was wondering, Juliana or Phil, any thoughts on that?
I do. I agree with everything, and I'm thinking on some other factors. I also thought a lot about the benchmark, and every time I discuss with people about that is that what is the benchmark that we're comparing to. But two other things that I think are key here for the LCA are, and that are kind of the definition of life cycle, and it's that beginning of life of the materials and then the end of life. In the beginning of life, I'm thinking a lot about the feedstock, the biomass that is being used to grow these materials, because everyone seems to be talking about a waste product, a waste biomass, but in reality, most of these materials are really not waste. They're also not free. I've keep hearing they're basically free, and they're really not. Biomass is not, even if it's waste, they might be free for you right now at the scale, the smallest scale, but when we scale these materials, you are not going to be able to find them for free, because even if you do get them for free, the logistics of getting them to the place are going to have a significant cost. And that billion-ton report from the DOE, the Phil mentioned, kind of projects a cost of about $60 per ton for the biomass for these to be feasible. So, and this material in storage, it can only be collected at certain times of the year. So the rest of the time it requires storage. Because this material is not sterile, it produces self-heating. There's microbial activity there. So there's fire risk, and there's many other things. There's a lot of material losses through the storage because there's microbial activity. And then just moving it around is so difficult. It doesn't weigh that much, but it occupies a lot of space. It has a very, very low bulk density. So just moving this material around from the farm to the storage, from the storage to the plant, from one part of the plant to the other, you cannot pump this material because the flowability is terrible. Chopping the material to the right particle size is super energy intensive. And all of that is going to have a lot of influence. And when we scale these a lot, then the availability of material might not be there. And that might push farmers to start growing biomass for these applications, which is a good thing in some ways, more demand for these materials. So they might grow dedicated crops to generate the biomass. But when we have changes in land use, land that is being used for something now starts being used to grow the biomass to make these materials, the impacts on LCA are huge. So that could make the difference of making this material sustainable to unsustainable. So that is a very important thing that we need to think when we're talking about scales. These scales, if it's really only waste material, agricultural waste. It's still not free, and it's still not free in the economic perspective or in the environmental perspective, but it is more feasible. But if there's not enough material out there, this is gonna change a lot. And then the final point, as I said, that's beginning of life and end of life, I think is key too. And end of life is mostly on the point of how long these materials last. And as I said, the materials I've worked with, they get used very fast. So the LCA is not very good. I'm very encouraged about these materials like leather, such as leather or building materials that I feel like they're gonna last longer in their applications. That's usually very good for the life cycle. If these materials are gonna last 20 years, 50 years, 100 years in a building, then the life cycle is likely going to look better.
One other thing that I could add is that one of the problems that currently in the construction industry and for buildings in particular, we have is the weight of the buildings. And I think I see a lot of potentials for this MySpace materials to create lightweight structures. But of course, we have to see what is, again, the comparison group. What are we comparing them with, and an equal or equivalent structure in terms of concrete or steel? What would be the MySpace if they have a structured strength to be comparable? Or if we're talking about other products, other construction materials, how more lightweight these products would be as compared with them, and that could be again a good argument to use in favor of these materials.
I just want to jump in to kind of reiterate and some of the things that Juliana and Rahman were bringing up. I think in describing the LCA, the standard, again, like these kind of how do we figure out actual numbers on things, put real numbers on things that are happening, and what do you compare it to? This was always an issue for us when we started off, or when we were doing our initial engineering tests. We were like, what is the zeroing out point? Like, we don't even know where to start. Like how do we begin to figure out how to measure this, and what are we measuring it against, and what do we even know is normal? How do we figure out where to pin our first, certainty around this? And so there's just a huge need for information and engineers to help in figuring out that kind of stuff. And then the LCA, it's so complicated. What we figured out is you can get the more precise you are in the description of your process, the more realistic the LCA. But if you have not yet figured out your efficiencies, or say you're a provider of muslin, you can't really come up with a very accurate LCA of what you're doing because you don't have a good data yet. So it's notoriously variable. This is something like a universal LCA could be created and would be incredibly cost effective for the investment into it to think about these materials. So each player doesn't have to come about it independently, but that this cost of whatever that would be, $5 to $50 million, would then serve all these industries, or would take that burden off of having some kind of formula, so that as you're getting closer to your ideal, there are existing algorithms or formulas to help one at least figure out a ballpark to project within. So those are some, again, and that doesn't exist. That would be incredibly beneficial. Nobody's working on anything like that. And huge needs for organs or organizations of that dimension. And then what Juliana was talking about, a lot of these industries are coming out of the hiccup that was biofuels industry and the attempts to scale up. The agencies, Joint Genome Institute, Pacific Northwest National Laboratory, all of these are daughters of the Department of Energy, various research areas of excellence that were really kind of put in place to help to create the bioeconomy, but based on biofuels on solid state. materials, the conversion of that into some liquid energy source. And so, you know, we found a ton of stuff within there, but again, like exactly like she described, like that was part of why we chose where we were, was because of those sawmills that had been there for over a century, and to have a consistent supply of red oak and pine mix that they have been producing on that location. And, you know, like that was a really strategic part of why we're in that area, is to have a consistent feed source. But those things are not obvious as you're beginning a company, or to even get that advice, or to help to think about where, you know, your end factory might, you know, there are certain restrictions on where you might effectively and economically be located to produce any of these materials. And again, access to water, access to freeways, access to ports, access to workforce, access, you know, all that stuff is, there's only so many places. We had a menu list of places we could go to within the criteria that we had to satisfy. And those things had to be, again, all this stuff had to be tailor-made, and expensively so, to figure out these particular scenarios. So these are things that would help all of these industries, all of these different companies, all of these interests to flourish, are these support mechanisms that are currently not in place, and need to grow into being as much. And again, this is where I feel like, ultimately it goes to policy and structures. The businesses desire that. All the corporations, all the fabricators want some standard to work within. And so it's not that they're against regulations, they just want consistent and clear ones, and those don't exist. So there's, again, like a lot of political work and whispering to politicians and talking to representatives about you know, making it an actual thing.
That is a fantastic discussion. So we're going to move to one of the questions on Zoom before we proceed with some of the questions here in person. So one of the ones that we have, and I encourage you to look at the chat because there's plenty of questions. Faisan Ali asks, what are some of the key challenges in terms of using recycled rubber as a potential alternative to leather? As in, this way we might be able to produce our desired product as well as reduce negative impact on the planet. How can we overcome any of these challenges? Any suggestions from our panel?
I don't know if we all know much about rubber, but what I will say is, in general, every time we talk about an emerging technology, we need to talk about what material is available right now. We're using rubber, you know, natural rubber, because it's needed. There's some applications that we can only use natural rubber. I'm assuming we're talking about natural rubber and not synthetic rubber. But we don't want to encourage more production. You know, we're trying to reduce, like the applications of synthetic rubber are bigger and bigger every time, because we want to reduce the use of natural rubber because of where it comes from, that is really not sustainable. So, you know, of course, using that in a circular economy in any way will be great. I don't know how its application on leather is, and if it can be used for that, and how effective it is. But I'll say, you know, any application like that will be very limited to only, should be to only what is being discarded right now. Because if for any reason we create a demand now for waste natural rubber, then it doesn't become waste anymore. And we will be putting more pressure into that resource that is already quite strained.
That is an excellent response. Thank you so much, Juliana. We are going to move to a question.
Hi, panel. Thank you so much for your answers so far, and it's been great discussion. I have two questions, actually. I think the first one might be for Juliana or Rahman. I've been told that the biggest cash crop in Pennsylvania is mushrooms for food, and that the second biggest cash crop is the feedstock for the mushrooms. Can you fact check that for me? Do you know about that?
I don't know exactly on the economics. I'm a little new to Pennsylvania, but I've been learning more about this industry for sure. And more people in my department are way more knowledgeable about this. But I've been trying to learn more about it. And yes, the biggest industry, the biggest mushroom industry in the United States is the one in Pennsylvania. It's in Eastern Pennsylvania, and they produce, I think, over 70 or 80% of the mushrooms in the country. Concentrated in a very small area. That also means the waste from the product that will be the same waste of materials of this kind. It's also concentrated there, which I know is a big environmental risk. If it is the biggest cash feedstock or agricultural product, I'm not 100% sure. It feels like a big thing to say, but mushrooms do generate a lot of, they have a lot of added value as an agricultural product. They're a specialty crop. In general, Pennsylvania is very big in specialty crops, and they do generate a lot of value, but not 100% sure.
I have a teeny bit of information. It's in the Kennett Square area where, yes, it's growing the kind of the white button mushroom, the sort of the champignon or the typical table mushroom. And Campbell's soup, that is like if you've had cream of mushroom soup, that is where those mushrooms are grown. And all of the mushroom soup that goes out to the United States is grown from mushrooms from there. But they
find that out.
That is how they came into being, and the existence of that industry. And it's generally smaller family farms that are also more working as cooperatives. So it has just an intensity of operators in a location that is allowed for a very unique production type. They use a lot of cow poop and manure in growing those, which is different from the sort of, we just need these, again, like more plant stock or again, things that grew as plants. And so they do help to ameliorate that waste, and that it's when it's composted and fed to the mushrooms. This is partially why those mushrooms are not produced. They used to be produced in mass in California, and when Nixon created the EPA, they could no longer do cow farming in certain areas, and so there was a loss of local cow poop to serve those, and so the industries collapsed here as a result of more regulation on cow farms and the usage of land on the coast. So it's where there are a lot of animals. This is why New Zealand, this type of thing, because they have so many sheep and everything else, and so they have a lot of poop in this, so they generate in that region, like they just use that as part of the research. So I don't know about that statistic of like if that's the biggest cash crop or if they have a loss of poop to use. I don't know. Like that's an interesting challenge, bringing up Juliana's, like, is there now a production of poop to serve that market? I don't know. Like it's like I don't know. Like is that the?
I love this conversation. What I heard is that the second biggest cash crop is hay, which is fed to the cows, which then poop and then feed them. That is what I've heard. But surely I will get to the bottom of it.
Yeah, my name is John Pecchia. I can speak to that a little bit. It is the #1 cash crop for PA. I don't know about the waste or the feedstock being this #2. And the mulch is used. It's not as a feedstock for the animal manure. It's actually used as a raw material for the composting for the production of the mushroom. And Phil's right, it's the button mushroom. The waste product is a problem. We generate an incredible amount of it in Southeast PA, primarily in 2 counties. So finding alternative uses of that raw material would be beneficial. And the primary ingredients, it varies regionally, but here in PA consists of straw-bedded horse manure and mulch hay. And in other parts of the country, it's primarily wheat straw or straw-bedded horse manure. But the raw materials, same concept that what you mentioned earlier up there is, we always considered all these raw materials as a waste stream, and recycling the waste streams for beneficial to make food. But because of all because it's a carbon source, there's a lot of interest in these carbon products. So raw material availability is always a challenge for the industry. And if you have other mushroom questions, I'd be glad to answer.
I was pretty sure you would know.
All right. Well, we are going to stop our panel there, our very insightful panel. So thank you all so much. Let's give a round of applause to our panelists.